All right, my lovelies, let's open up to page 121. We're going to continue to discuss our different factoring techniques today that we were reviewing on Friday, and we're going to see how we can use factoring to help us analyze different graphical characteristics about these polynomial pictures or graphs. So on 121, we're going to go through three kind of visual examples to help this make sense. And then we're going to transition into the next section, which is going to continue to involve factoring and graphical analysis. We're just going to take a look at a different characteristic. Okay, so we're going to be factoring and looking at graphs a lot in this particular unit. Looking at our first example, can we think of a factoring technique that we can apply to this polynomial? GCF, always try that first. Okay, what can we take out? A 3 and an x. So we're left with x squared plus 4x plus 4. All right, GCF is a technique. We should always try it first, whether we can or cannot do it. It depends on the problem, but always try it first. So we're done with GCF, but we got to ask ourselves, can we keep going? Don't force it, okay? Don't feel like you have to keep going, but you just got to ask yourself, can you keep going? Is there another technique that we can do? Yeah? That's what I call it. Yeah, I am, where the a value is 1. So I really don't know if there's an actual name for that. That's just what I call it. So can we think of two numbers that multiply to 4 but also add to 4? 2 and 2. Okay. So we can do x plus 2 and another x plus 2. You can leave it like that. Some of you might notice that if you have x plus 2 times itself, you can write that as x plus 2 squared. Okay, either way, they're both completely factored. So, utilizing these techniques from Friday, we're going to try to analyze how these factors are related to the graph of the polynomial. And in order to do that, we're going to solve the factors. That just means that we're going to set them equal to 0 to see what the x solutions would be. And if you take a look at perhaps this simplified one here, we have 2 x's, so we should have 2 answers. Can we think about what our solutions would be for x if we want the individual factors to be 0? Yeah?
Negative 2 and 0.
All right, so this first x, you got to think about 3 times what number would be 0? That'd be 0. Yep, so that makes this GCF factor 0. And then for the other factor, you got to think about what number plus 2 would give you 0, and that would be negative 2. Okay, so we found the x solutions. We got to think about how are those related to the graph. Can we see where 0 and negative 2 are kind of showing up in the picture? Yeah, Caitlin? They're x-intercepts. Notice how these are x solutions, x equals 0, x equals negative 2. So those are actually on the x-axis. Okay, those are your x-intercepts. Now, what we are going to spend some time on later on in this unit is discussing the difference between these two x-intercepts. Notice how at this x-intercept you just touch it, whereas this one you actually go through it. Okay, we're going to kind of analyze that difference later on, but for now, if we can find them, that's kind of the big key. So these are your x-intercepts. Something else we can analyze from a graph and how it's related to the equation is the y-intercept of the graph. And looking at our graph here, the y-intercept would also be 0. Can you think about how this y-intercept of 0 is related to the equation at the top? This one might be difficult. At least for this example, it's kind of difficult. What do you think, Blair?
Plus 0.
Plus 0 on the end, right. So we have x to the third, x squared, and then x. Notice how you're missing that last number on the end that doesn't have a value or variable with it. That's called a constant term. Constant because there's no variable, it's never going to change. So the constant in this equation happens to be 0. Little coincidence? I think not, right? Okay, we'll see how that relates to some other pictures. It's never coincidence. Nope. All right, I'll let you know if it is a coincidence. Take a look at the next one. Can we think about some factoring techniques? Can we find these x-intercepts by hand? Let's see, we can maybe cheat a little bit. We know where the x-intercepts are based off the graph, right? We want to try to see if we can get the same solutions from the equation. Yeah?
You could do x squared minus 4 and x squared minus 1.
Okay, so this is another example of that I am factoring because the a value is 1. Two numbers that multiply to 4 but add to negative 5. Negative 4 and negative 1. What's a little bit different with this equation, though, is notice how it's a quartic. It's a power of 4. So instead of x and x, like we typically do for quadratics, these have to be x squareds, because 2 and 2 would give us that 4. So we're done factoring using the I am method or technique. You got to ask yourself, can you keep going? Yes. What can we do? It's the difference of squares. All right, so the first factor, x plus 2, x minus 2, and the second factor, x plus 1, x minus 1. Notice how we don't have any powers left, so I'd say we're completely factored. So if we solve these individual factors, what would make each individual factor be 0? We'll have negative 2, positive 2, negative 1, positive 1. And it looks like that checks out from the graph. Here we found those x-intercepts. Now, in terms of the y-intercept, we can visually see that to be 4 based off the picture. How is the 4 related to the original equation? It's the constant. That's right, Logan. It's the constant. Okay, the 1 on the end, no variable with it. If you think about y equals mx plus b, what's been kind of beaten into your brain since Algebra 1, isn't b the constant on the end? That's your y-intercept. Okay, polynomials kind of work the same way. Looking good. What about the last one? Can we think of a factoring technique? What do you think, Blair? Grouping? How'd you know grouping? There's 4 terms. All right, so 4 terms is kind of a clue into grouping because we can do 2 and 2. So GCF out of the first group looks like x squared, and we're left with a 2x plus 5. Can we take a GCF out of the second grouping so that we have a 2x plus 5 left? Because they need to match. We can take out a negative 1. Good. All right, so grouping factors, we'll have the GCFs, x squared minus 1, and then the matching factor, 2x plus 5. So we're done with grouping. We got to ask ourselves, can we keep going? What do you see, Olivia? Difference of squares. Good. X plus 1, x minus 1, and then 2x plus 5 will stay. So if we solve those factors, we'll get negative 1 from the first factor, positive 1 from the second factor. What about the third? How can we get 2x plus 5 to be 0? Maybe you actually want to set it equal to 0 to help you solve it. Go, Noah. Negative 2.5, okay, or negative 5 over 2, however you want to write it. Okay, you can subtract the 5, divide the 2. So you can leave it as a fraction or convert it to a decimal. All right, negative 2.5. Maybe converting it to the decimal would be a little bit more obvious when we actually check the graph itself. So here's the negative 2.5, and then negative 1 and positive 1. So it looks like our factoring was correct. In terms of the y-intercept, looks like we have negative 5. And notice how that is the constant term from the equation. So by analyzing an equation, we can think about where different graphical characteristics, in this case intercepts, are located. So just as a little summary, we'll go ahead and write down how we can find x-intercepts and y-intercepts. Well, really you only have one y-intercept, but how we can figure out intercepts based off the equation. So x-intercepts came from the factors when we solved them for 0. So we want to factor and solve when it equals 0. The y-intercept is pretty nice because there really isn't any math necessarily involved with that. It's more of a recognition type thing where you have to find or just realize where that constant term is. So we'll say this is the constant term. Are we good with those characteristics? Kind of a review from earlier this year. Okay, again, just bringing it back because we're going to be using these characteristics quite a bit in this unit. So what we're going to try to do now is use these factoring techniques and intercept recognition tools to help us analyze more characteristics about these polynomial graphs. So our next section on page 125, we're going to bring back some of that function notation that we've looked at earlier this year. And we're going to talk about greater than 0, less than 0, what if we can equal 0. Okay, if you can recall, these were asking us where we are above the x-axis or below the x-axis. So specifically looking at these roller coaster type graphs, can we figure out those intervals? All right, so taking a look at the top, we have this function, and they were kind enough to give us the graph as well. So we have various pieces of information here. We can clearly see where the x-intercepts are because we have the graph available to us. But let's pretend for a second that we didn't have that graph. Okay, let's try to figure out where the x-intercepts are by hand. So we're going to go ahead and try to factor this and then solve it for those values. Can we think of a factoring technique to help us out? Is there a GCF we can remove? Yeah, looks like an x. So we're left with x squared plus x minus 6. So we're done with GCF. Can we keep going? Bless you. Let's see, maybe the I am method would be appropriate because our a value is 1. Can we find two numbers that multiply to negative 6 but add to 1? Yeah. Negative 2 and 3. All right, so completely factored. We got to solve for x. So notice how we have 3 x's. We should have 3 solutions, okay, 1 for each. So the GCF factor was just x. So in order to make that 0, itself would have to be 0. The next factor of x minus 2, if we solved it for 0, would give us a positive 2 because we have to kind of like counteract the negative. And then for the next factor, if we had to counteract a positive 3, our solution would be a negative 3. So it looks like it checks out, negative 3, 0, and 2. All right, so those are our x-intercepts. So now that we have the graph, maybe we can go ahead and determine where these different intervals are located, where we equal 0, where we're positive, where we're negative, aka above the x-axis or below. We'll see if we can kind of bring this back from earlier this year. So where we equal 0, that's where we are on the x-axis. and we conveniently found those numbers by factoring or by looking at the graph if we have that picture. Can we think about where we are positive, aka above the x-axis? If you actually trace those intervals, it looks like we'd have 2 of them. So what might those intervals look like if we actually wrote them out? We got to think about brackets, parentheses, what's appropriate. Good, Julia? Yeah. Perfect, okay.
And then a U, and then 2 with parentheses, and then a comma, and then infinity.
That's great. Okay, now why'd you use parentheses instead of brackets?
Because the -3 is touching the x-axis, and so is 0 and 2.
Mm-hmm.
And you can't reach infinity, so.
All right, so perfect. We cannot include these because they're on the x-axis. This question is just asking us where are we above. Okay, so we can't include that, and we'll never ever reach infinity ever, so we'll have a parenthesis in that case. Looks good. If we do kind of the reverse analysis where we below the x-axis, you can highlight those in with a pencil. So very similarly, we'll have -infinity to -3 with a parenthesis, and then 0 to 2 with a parenthesis. We cannot include those values. That's not necessarily the case for the next two, because notice how we have a bar now. So in this case, we can include the x-intercepts because we are on the x-axis. So if this is basically the same interval as previously, it should look pretty darn close to what we had before. How do you think it's going to change, though? The notation changed, so maybe the interval will change a little bit. What do you think, Elsie?
No big brackets, 0
There we go. So all those x-intercepts, -3, 0, and 2, that we found from factoring, we can now put brackets on those because in this case we can be on the x-axis. So notice how it's a very similar notation. It's using the same numbers, but what's different is the brackets and parentheses. Okay, it means a world of a difference depending on the question at hand. So very similarly, if we want to be below the x-axis, it should be similar to the previous one. But if we can be on the x-axis because of the bar, we should be able to include those x-intercepts now. So we'll go ahead and use brackets. Okay, so we spent quite a bit of time earlier this year talking about above x-axis, below x-axis. We're going to bring it back for these polynomial functions. I know we can do this, but what we're going to try to do now is shy away from the graph and see if we can get the same analysis just looking at the equation. Okay, so we're going to pretend again that the picture isn't there. We know what the answers for these particular intervals are. We're going to see if what we can get by hand verifies this. Okay, so we can essentially check our work. So we're going to take a look at the same equation and notice how we want to be greater than or equal to 0. So we want to be on or above the x-axis. Just like some other processes that we've gone over this year, I've given you some kind of guiding hints in the table format. But this process that we're going to do here is very similar to the number line that we did for absolute values. Remember doing that? It's going to be very similar. It's not going to be exactly the same. Okay, it's very similar. This is what's called a sign analysis chart, sometimes sign chart for short. This is a process that we heavily use in AP Calculus or regular calculus. We definitely use it more in depth there, but it's definitely something useful to learn or understand in this course. We're going to apply it to just polynomials. In AP Calc or regular calc, we do trig functions, we do exponential functions, we get a little bit more in depth. Okay, but here we're just going to do polynomials. So if you think about how we did the sign chart for the absolute value, remember we had to find those vertices, and those were the numbers that we used on the number line. We're going to do something similar here, but instead of the vertices, we're going to use these x-intercepts that we can find. So we're going to factor the polynomial, and if this is the same one that we already had before, we can just copy down the factors from the top. So using a number line, we're going to write in order, okay, from left to right, the x-intercepts. So the first one that we listed was -3, then 0, then 2. So now that we have the number line set up, this is when we're going to choose any x value we want, whatever we're feeling today, to plug into the equation to get the sign. Okay, if it's positive or negative, that's just what we're looking for here. I don't care about the number. So what number are we feeling between -infinity and -3? We don't care? Okay, we'll pick -4 then. All right, -4. So what we're going to do, with whatever number you pick, we're going to plug in that number into the factors. Okay, not necessarily the original, okay, the factors. So if we were to plug -4 into this lonely x, it would be negative, okay, because it's just a -4. So our first factor is negative. If we were to plug -4 into the next factor, we'll have -4 minus 2, which is -6, and that's overall negative. The last factor would be -4 plus 3, which is -1, and overall that's negative. So this is where it's a little bit different than the absolute value analysis, because remember, once we figured out positive or negative, we distributed it in. Okay, we're not doing that here. We're just taking a look at the sign, okay, positive or negative. So from here, if these factors are being multiplied together, what would happen if we multiplied these signs together? Negative times negative times negative? Negative, okay? So what we just determined is that this polynomial, this graph, whatever it looks like, on the interval from -infinity to -3, it's negative, aka below the x-axis. So the reason we're using the x-intercepts as kind of guiding points is because we know that the graph is on the x-axis at those spots. And if it's only on the x-axis at these locations, that means it's either above or below in all the other ones, because those are your only other two options. So that's what we're checking. Are we above or are we below on these other intervals? So if we check the next one, pick anything you want between -3 and 0. Maybe -1. We're going to plug it into the factors. So our first factor would be negative. Second factor, negative. Third factor, positive. Negative times positive. Positive. Looks good. So it looks like from -3 to 0, we are above the x-axis, aka positive. Next interval between 0 and 2, probably 1. We'll plug it in. Positive, negative, positive, all multiplied together, we'll get negative. All right, and anything you want bigger than 2, maybe we'll pick 3. So we'll get positive, 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 all multiplied together, we get positive. Now if we really pay close attention to this, because we do have the graph available to us, notice how from -infinity to -3, we are below the x-axis, aka negative. From 3 to 0, we are above the x-axis, aka positive. 0 to 2, we are below, and 2 to infinity, we are above. So it's checking out based off the picture that we had. Okay, this is just a visual way for us to determine that without having the graph available to us. Okay, we're just using the equation now, no picture necessary. So what we can do now is that since we have the information, we can go ahead and answer the original question. Where is this equation on or above the x-axis? What should we be looking here to help us determine that? What is this chart telling us? Can we find those spots? What do you think, Noah?
-3 is 0, and then 2 is infinity.
Okay, so we're looking for, in this case, we're looking for the positive locations because we want to be above the x-axis. What about if we wanted to be on? So we're definitely looking here and here. What about the on part? What do you think, Blair?
Would be brackets.
It'd be brackets. Okay, so this x-intercept of -3, we can include that. This x-intercept of 0, we can include that. This x-intercept of 2, we can include that. And if this is going to go all the way towards infinity, we'll need a parenthesis there. So if you want to throw in those symbols, it might be beneficial for you so that we can visualize what the actual interval answer would look like. So we're going to need bracket -3 to 0 with another bracket. Okay, so that's our first interval. And then since we had another one, we'll throw in the u. We need bracket 2, comma parenthesis, or comma infinity with a parenthesis. Does this match the same solution we had from the chart when we just looked at the graph? You see? Greater than or equal to 0? Okay, number 4, it matches. So what this is giving us is a way to determine how a graph is behaving, where it's located, without actually needing a picture. Okay, we can do it by hand, analyzing the equation. Let's go ahead and try another one. Okay, again, we'll take a look at a picture just for us to gain some confidence with this, and then probably tomorrow I'm going to take them away. We're going to try to do this by hand. Okay. All right, so on the next page, looking at our equation, can we think of some factoring techniques? If we look at the actual graph, it looks like we should have 3 x-intercepts, and one of them is -3. The other 2 are kind of iffy because they're not at whole number locations. So it might be a little different, yeah.
Yeah, back by grouping.
Grouping, we have 4 terms. Okay, so GCF out of the first one, maybe a -x squared. We're left with x plus 3. GCF out of the second group would be a 2. And we're left with an x plus 3. So after all is said and done, we have the GCF factor and the matching factor. So we're officially done with grouping, but ask yourself, can we keep going? Are we done? You can say yes, okay, because I don't see a difference of squares. None of those fit the IAM profile, okay? But there is something you could do if you really felt like it. You see how this x squared is negative? Okay, you could take a negative out of this group and it would just change the signs. Okay, so I'm not saying you have to do that, but if you felt like factoring further, I guess you could count that as a GCF, something that those 2 terms have in common. Okay, so what we got to do is try to solve for x here to find our x-intercepts. This last factor is pretty simple because we have to counteract a +3, so that would be -3. But notice how the first factor has an x squared in it, so it's going to be a little bit more involved for us to solve for x. And you might actually want to set up an equation to help you do that if it's necessary. So if you solve for x, you can add the 2. And then what happens if you square root both sides? We said we should have 3 answers. And right now we only have 1. Plus or minus, that's going to give you the other 2. So this would be plus or minus the square root of 2. So -3 should be an x-intercept, which checks out based off the graph. But then we also have positive and negative square root of 2. So those are probably the other ones that were a little iffy because they were not on a whole numbered location. All right, so we have -3. This will be negative square root of 2 and then positive square root of 2. All right, so let's take a look at some analysis here. Where are we above the x-axis? Where are we below? The first one, though, is asking us where are we on the x-axis. So those should be the solutions we got from factoring. If we want to look for where we are above, maybe you want to trace those sections. Let's see, the first section will have negative infinity to -3 with a parenthesis because we cannot touch the x-axis. And then the other interval looks like the negative square root of 2 to positive square root of 2. Again with parentheses because we cannot be on the x-axis. For the next one though, we're going to kind of switch it up. We're going to see where we're below the x-axis. So -3 to negative square root of 2, and then square root of 2 to infinity. Maybe I'll make those red. Now for the last two, kind of similar notation, but now we actually have a bar, meaning we should be able to include the x-intercepts. So the intervals should be exactly the same, okay, just with brackets instead of parentheses, but that's only on the x-intercepts. So we'll have a bracket on -3 and then bracket negative square root of 2, positive square root of 2. Bless you. And then we can do the same thing for below. Bracket -3, bracket negative square root of 2, bracket square root of 2, and infinity still has a parenthesis. So we know every possible interval, whether we're above or below or if we want to include the x-intercepts. Let's see if we can get the same result by hand. Okay, we're going to pretend for a moment that the graph is not there. So if you take a look at our question here, we want to figure out where is this equation, which happens to be the same as above, where is it less than 0, aka below the x-axis. So our result should look exactly like number 2. We're hoping that we can get that. Okay. So the first thing is we're going to find those x-intercepts. We're going to factor the equation. We already did that at the top, if you want to go ahead and write it down. And we said our x locations were -3, negative square root of 2, and positive square root of 2. So those are going to be the numbers that we circle on our number line. All right, let's pick some values. So anything you want between negative infinity and -3, maybe we'll choose -4. So we're going to take -4 and plug it into each factor. Notice how, though, we have this negative out front, okay, that we removed when we factored previously. This negative needs to be included because it's affecting where your graph is located, if it's above or if it's below. So if you wanted to, it might not be a bad idea to just put that negative in every interval. Okay, that's the negative out front. If we were to plug in negative 4 into the first factor, negative 4 squared would be positive 16, and then minus 2, so that's a positive answer. And if we plug in negative 4 into the second factor, that would be negative. Okay, so we have the negative out front, the positive from the first factor, the negative from the second factor, all multiplied together. What are we on that interval? Negative times positive times negative? We're positive. Okay. And if you look at the graph, that should make sense. Okay, we're positive before negative 3. Pick something between negative 3 and negative square root of 2. Negative 2 might work. All right, so we have the negative from the front. If we plug in negative 2 into the first factor, that'll be positive. And if we plug in negative 2 into the second factor, that will also be positive. Negative times positive, negative, and graphically it makes sense. Okay, we're below the x-axis. Pick something between negative square root of 2 and positive square root of 2. 0 would probably make the most sense. All right, so the negative from the out front, the first factor, if you plugged in 0, would be negative. The second factor, if you plugged in 0, would be positive. All multiplied together, we'd be positive. Graphically, makes sense. All right, and then the last one, anything bigger than the square root of 2, maybe we'll pick positive 4. If we plug it in, we have the negative out front. The first factor would be positive, and so would the second. So all multiplied together, we'll get negative, and graphically checks out. Okay. Again, we're pretending we don't have it, but notice how it is making sense. So this question was just asking us where are we below the x-axis. So we should be looking for perhaps that negative location. We got to ask ourselves, what about the sign, or not the signs, but the brackets versus parentheses. Can we include these x-intercepts if we just want to be below? I'm seeing head nods. That's good. So parenthesis, 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 parenthesis. So we'll write it out. Negative 3 to negative square root of 2, all in parentheses. Positive square root of 2 to infinity with parentheses. And it matches number 2, just like we said it should, right? Looks good. Oh, not number 2, 3. My bad. Number 3. Okay. Checks out. All right, so we're going to try a few more of those processes tomorrow, but we're going to do it without a graph to check our work. Okay, we're going to have to kind of trust our gut, if you will, with those types.
What? Interval where it's like above 0 or something. And then